All right, everybody, happy Monday. Welcome back to OpenShift Commons, and today's briefing, we have Steve Sloka here, who's a maintainer on the Contour project, to give us an update on Contour, Ingress, and all the goodness that's happening in the Contour space. I'm really thrilled to have him here. He's, going to walk us through this whole arena, and as well afterwards, after he's done with his talk and his demo, we'll have live Q&A, and you can ask your questions in the chat wherever you are, whether you're in BlueJeans, Facebook, YouTube, or on the Twitch station. So Steve, take it away, and let's learn today all about Contour and Ingress.
Okay, awesome. Thank you. Well, welcome everyone. Thank you for coming. Yeah, so today I wanted to give you an intro to Contour, give you a quick background as to what Ingress controllers are. And then we'll roll into some of the CRDs that we've written to help solve some of the issues we've seen with Ingress. And then that should be like a third of the talk, and then hopefully the last 2/3 is all just live demos. Conveniently, my laptop just rebooted trying to get BlueJeans to work. And my other 3 clusters that I was going to do this off, I broke my DNS with Let's Encrypt. So we're doing this locally, and I just rebooted, so I haven't tested any of it. So we'll be winging this today.
Oh, that's again, the best kind. That is the best kind, Steve. You're doing great.
Yeah, so here's the quick agenda. We'll just walk through, Ingress, what Ingress controllers are, our HTTP proxy CRD kind of thing, to introduce that, again, as sort of unique to Contour. And again, we'll just do some demos at the end. So yeah, I work for VMware. I came out of the Heptio acquisition. That's where Contour was started. So that's my main.
Steve, hang on, pause for a second. Your slides are not advancing if you have advanced from the title slide.
I have, yeah.
Okay, so let's hit you're having BlueJeans fun today.
I know. Let me I'll stop and restart. How about that?
And we have plenty of time, so.
How about now? Do you see it now?
I do not see your slides. There's a little, at the top of the screen, there's a little slide projector, kind of terminal mode. There you go. Now I see it. For half a second I saw it.
I just stopped it, yeah.
And I saw your agenda. Yeah.
Yeah, good.
Nope, not yet. I'm not seeing it. Chris, are you seeing his slides? Try refresh. No, we're not. We just got a black screen here. So if you have, oh, Ruben sees the agenda. I saw it for a nanosecond.
Excuse me, it says I'm sharing. I don't know.
Okay, other people can see it. That's quite okay. Drive through, I will be fine with it as long as now I can see it now. There you go. About me. Perfect.
Yep, that's it. Yeah. Okay, good. So we'll move on out of that. So yeah, give me a shout. Let me know if folks have troubles or questions, whatever. Excuse me. So what is Ingress, right? When I think of Ingress, I think of incoming, just generically that word Ingress. So this is the problem that Ingress looks to solve in Kubernetes. So the idea is that we want to route traffic from outside of the cluster into your cluster. So, break that boundary in some unique ways. So why do this? Why implement this thing? Well, you can get traffic consolidation, right? So you can have lots of different applications all drive into one entry point. If you didn't use Ingress, you might use something like a service type load balancer, which would map a service in Kubernetes to some sort of external load balancer, depending on your deployment environment. And that would work, right? You'd get some sort of L4 load balancer on the end. The problem then is you've got one of those load balancers per application. So one, you've got to deal with a cost of just spinning up that many, and 2, you've got to deal with the complexity of having all those different entry points into your cluster. So with Ingress, you can consolidate all of those things together into one place. Once you have this traffic consolidated, you can now centralize your TLS management. So all those certificates that you want to deploy, you can do that once now at the edge in this one place, again, instead of having to deploy this on every single little endpoint across your cluster. Contour has this neat idea, and we can talk about this later, this idea of TLS certificate delegation. So this will help with this certificate bit. But the idea is that you can have your certificates live in one namespace and reference them from a different namespace. And this will actually work with plain old Ingress as well. And again, we'll dig into this a little bit later. Ingress lets you abstract your configuration. So again, when you're deploying your application, you don't have to wonder or deal with, all right, I've deployed my application, I have this load balancer, now I need to map DNS to it, I need to map certificates. you can just basically deploy your application and then let the ingress layer kind of be that glue to wire all these little bits together. And then the other big win that you typically get with ingress is this path-based routing. We call this sometimes L7 or layer 7 of the stack. And this is your application routing. So it lets you route things like /foo to one application, and that's the request path, and /bar is a different application you could route somewhere else. So you get this L7-based routing. So what is an ingress controller? Well, this one's specific to Contour, but this should fit any ingress controller out there in the world typically. So again, you have the internet out here. You have traffic hitting some sort of load balancer, and that load balancer then hits some sort of proxy. So in Contour's case, we leverage Envoy. Envoy is a CNCF project, and it is our proxy layer. So it handles all of the heavy lifting in terms of routing traffic across the cluster. Contour's job in this scenario is it's the controller for Envoy. So in Envoy speak, Contour is the XDS server for Envoy. So XDS is a protocol that Envoy can speak. And so we create a gRPC connection between Contour and Envoy here. Contour then watches the cluster, and it looks for things like services, endpoints, secrets, and different kind of ingress objects. When any of those things change, Contour will build up a new configuration, and it will pass that down to Envoy, again, over that gRPC connection, and then Envoy will consume that and then serve traffic off that configuration. So this box in the middle here, you could swap out with any other kind of controller, and I think this should probably fit pretty well with any other kind of ingress controller. If you haven't seen them before, this is a very basic ingress resource. I throw this in here just to be complete. But here, we've got the kind is v1, so this API version v1 is new in 1.19. Any previous version, you'll see the v1 beta 1, which has been there for 6 or 7 years now. So you can see here we're going to route, this is HTTP, so we're going to route /test path to the service called test and the namespace wherever this is deployed. So this is a real simple example of doing that L7 type routing. You notice I have an annotation here as well. We'll get into that here in a little bit, but to extend the API, you typically add annotations to these resources to help make them more descriptive and have more features into there. All right, so we talked about ingress. So what are some of the issues we've come up with? Well, one thing, it's a specification. So this is a slide from Dave Cheney. Shout out to Dave. He gave a talk out in KubeCon China in 2019 about sort of some of the limitations we've seen with ingress today. So if you want to watch his talk, you can do that. I think it's still kind of relevant. He'll talk about ingress route, which is, again, something we've deprecated out of Contour, but all of the learnings should apply going forward. And one of the things that Dave hits on is that ingress today is just a specification, right? And a lot of how you specify things are in these comments in the code. So this is from the actual code. I think this is probably a year or so old now, but the idea is that you have to interpret these rules, right, and how these things are described. So I guess what we're getting to is that depending on how the ingress controller interprets these different kind of ingress resources is how that controller behaves. And if someone interprets them differently than someone else, then you get ambiguity now across different controllers. So you can't just swap in one controller for another and have everything just work. So some of this stuff gets us into trouble in the sense that we don't know how to properly implement it, and we have to make up our own design. So let's talk about a situation here now. So given that, let's look at these two different ingress resources. So the one on the left here is an ingress resource deployed to the namespace team A, and the one on the right here is going to team B. And you'll see they both have the same host. So this is stevesloka.com in both resources, and they have the same path /blog. But you'll notice that they go to different endpoints. So the first ingress resource points to WordPress blog, and the second one points to service new. And the question here is that I have two different ingress objects. They have the same namespace, the same path, and the same domain, but they point to different places. So what should happen? And again, this is totally legal. Nothing is broken here in terms of Kubernetes objects that you can apply to a cluster. This is valid YAML, I guess. But what should happen when your controller reads this, right? And the problem is that it's undefined, because you could think of that maybe the first one in wins. The first resource with that same domain should serve that resource. Maybe the last one in should win. Maybe they both shouldn't. They should be thrown out because they both conflict. And we've seen production users break their clusters this way. Unknowingly, not doing it on purpose. Just because they happen to deploy, a dev version to a different namespace, and then they kind of conflicted with production and took it down. So it's undefined, it can be dangerous. And this is sort of the underpinnings that led us to building our own CRD. So Contour started out building one called Ingress route, and we since deprecated that and built a new one called HTTP proxy. And this is sort of the successor of that. So you'll see some of these underpinnings from Ingress route if you're familiar, and also in some of the service APIs work. So there are some learnings in there as well. So some of the goals we had for the CRD, they were to support multi-team clusters. So we wanted to have a way that, in that scenario we just described, we can have lots of different teams self-manage their own resources, but have them do it in a way that they can't conflict and can't create those situations where we take down production. We do this through this thing called this delegation of routing. So you're able to set up, what team can access what information and what path on the request, and then each person can self-manage that. And we'll dig into this here in a minute. We'll show some demos of this. A third option or third goal was we wanted to have a sensible home for common configuration parameters. So we talked about those annotations on those resources. So one was service weights, one was load balancing strategies, one is path prefix rewrites. Because the spec again is not well defined, there's lots of places where we need to add more information. There's not a good place for it, so we end up adding those as annotations. So again, our CRD was hoping to remove some of that and have a sensible place to put those in the spec. And again, the delegation of secrets we talked about, that was another kind of win. So in this diagram here, you can see that this is going to talk about the delegation bit and how we actually implement this. So and it's sort of modeled after DNS in a way. So here you can see I have this CRD here, this stevesloka.com HTTP proxy. And what it has is it has authority over a domain name called stevesloka.com. And this is what we call the root sometimes. So the top level is what we call our root. Now I can go and create a delegate version of that. And I can say, hey, this delegate proxy has access to /blog. We can delegate authority to that. So now if someone else comes along and they say, hey, you know what? I'm creating a dev site called devblog, and I'm going to own /blog. What happens is this Contour throws it out because it doesn't have any authority over the path /blog, because this first one has it here. So again, this is a very simple view, but this is how you can actually implement this delegation across your cluster. Let this team here self-manage their own resource, and in the event that someone else does it either maliciously or just unknowingly, we can handle that situation and still serve traffic. Okay, those are all my slides. If anyone has questions, we can chat about that, but I figure we'll just dig into some things now. So what I'm going to demo is I actually my cluster is completely empty right now. So what I have here is I've got a kind cluster. I think it's a 119. Yeah, I've got a 119, a one node 119 on my Mac here. And what I've done is I've started up with a configuration file. And what I've done basically, and can't really see that, oops, is I've mapped port 80 to my local machine. So one thing we didn't describe was how I'm deploying Contour. So let's go ahead and deploy that, and as it deploys, we'll discuss that. So if you want to get started with Contour, there's a couple different ways. So I'm just going to use our quick start, which essentially just gives you like a kubectl apply in one file. So we'll just go ahead and grab this, and we'll deploy this one. This will deploy Contour. So let's go ahead and get everything in our namespace. So here's Contour. So by default, we'll deploy Contour as a deployment. And here we have two replicas of that. Again, Contour's job is to watch the cluster for services, endpoints, all those different resources. And then we'll have Envoy running as a daemon set. So Envoy's here, and then Envoy's going to have this thing called a Bootstrap configuration. And that configuration is what we pass to Envoy to essentially tell it where Contour is. So everything that Envoy gets configured with will come dynamically through those XDX resources. And again, that's through that gRPC connection. So everything's up and healthy, so everything should be running. Envoy is now talking to Contour. Again, Envoy's running as a daemon set, and it also is running with host ports turned on. So we ports 80 and 443 on, again, by default. And then I mentioned my kind cluster. So if I go back to my Docker, make this bigger for you. So you'll notice here that I've got on my local host 80 mapping to 80 in the container. So because my Envoy container is running, exposing itself to port 80 on the Docker node running in kind, and then I expose my local machine's port 80 to that port 80, and it's sort of crazy. I now have access from my local machine on localhost to port 80 in the container, I guess. So now I can curl localhost 80 and localhost 443, and I can get to the Envoy pod running in my kind cluster, just so you see how that works. Okay, so we have that running. So we have Contour up and running, but we haven't given it any configuration. So I go ahead and get my proxies and all namespaces. I'll have to deploy something first, but I have nothing in there. So let's go ahead and deploy something. So here I have some demos here. So first what we'll do is we'll deploy some apps. So I have to go create a namespace called root proxies. So we're going to put all of our root objects and proxies into that place. That's going to be my starting point. And here we're going to have a deployment. And what this deployment runs is a simple little echo server that I wrote. And it does two things. One is it echoes out the text that we put into the site here. And this will help us understand, which application is responding to what request. It can be confusing sometimes when you start doing some different kind of routing. The second thing it does is it echoes back the headers and the request that you sent it. So again, it helps us with debugging and visualizing this information. So we'll deploy a root app and then a service, and I think there's a secure app that we'll get to here in a second. We'll do this O1 app. Okay, there's that.
Can I ask a question, or do you want to wait until later?
Sure, yeah, go ahead.
So you mentioned it's deployed as a daemon set, so you'll have basically a copy of Envoy running on every node in the cluster.
Yeah, as the quick start's written, yes, you would. Which may not be what you like, yeah.
Yeah, so how does that work? Because there will be, in terms of networking outside going into the Ingress, it's up to you then, I guess, to define your routing, right? If the assumption is that every node in the infrastructure has its own IP address, and so there's a whole other layer here, part of Ingress, that Contour doesn't deal with, right?
Yeah, so again, back to this diagram here, like Contour right now is focusing on the spot to the right inside the cluster. So how you get traffic to Envoy is really up to your environment. And Contour doesn't deal with a whole lot with that because there's so much to it. So typically, if you're in a cloud environment like AWS or Google or something, you can create this service. Envoy is a type load balancer, so it'll spin up a cloud load balancer. If you're on premise or something, you could use something else like MetalLB or some other sort of information or tool to get traffic to Envoy. But Contour doesn't deal with going out and getting IP addresses and ports from your network and that sort of stuff. It's just the Ingress controller. So you'll need something else in front to fulfill this left half of this diagram.
Well, the reason I'm asking, I guess, is that that load balancer that comes from the platform, the public cloud or whatever it is, it doesn't know where the services are in the cluster, right? So you might have multiple leaps, right? If it goes to one node, but the service is actually running on another node, that happens inside Kubernetes networking at that point.
Right, yeah, so this load balancer is only going to point to Envoy. And then once the traffic hits Envoy, Envoy will decide where it should go inside the cluster in terms of what services. So you're only going to have one load balancer per instance of Contour. And then Envoy is going to do the routing to the actual backend application.
Well, per node if you're using the quick start, so.
Sure.
Yeah, okay.
Yeah, right, yeah. So you can change that. So if you're, and this comes up sometimes, we haven't, sorry, I'll go out to Contour here. So we call them examples right now, and we've kind of gone back and forth in terms of how to handle this. But right now the deployment docs, so the quick start comes from this source directory, and basically the quick start just smashes them together into one big YAML file. But we've called this examples because of this situation, right? There's different ways people want to deploy it. Some folks don't want to use node ports, or I'm sorry, daemon sets with host networking because you've got to have privileged containers then to get ports 80 and 443. We use daemon sets because Envoy scales very well with CPU threads. So adding multiple instances of Envoy per node doesn't really give you more performance. So that's kind of why that helps limit that. But you could absolutely deploy Contour as a deployment, or I'm sorry, Envoy as a deployment, and use different ways in Kubernetes to put that traffic across your cluster. We've had users have node selectors or other ways to target, these specific nodes in my cluster are used for ingress and the other ones aren't. Again, to limit the scope of where they go. So it's that's why we kind of call them examples, because there's so many different ways that folks might need to deploy this. You can modify it to your taste, I guess. Does that help answer your question, or am I still talking around it?
Sal, did that get you? Let's assume it has, and move on.
Okay, cool. So at this point we have some apps running, but we don't have any Ingress resources. So we'll do that next. So we're going to go ahead and deploy this one here. And what we'll do is we will go and deploy this proxy here. And this will look very familiar to the Ingress resource we just saw. But again, it's the project.contour.io version. We call it HTTP proxy. This one I'm going to call root. And again, we're going to put it in this root proxies namespace. Now the domain name, I'm going to use this local.project.contour.io. This is set up to use localhost out in Contour's DNS out wherever it's hosted. So now we can use that here on our local demos to help give us a good domain name to work against. And we'll just target the root app. So we'll go ahead and deploy this. This is real simple. And then this will get us up and running here. So we'll deploy O2 proxy. My YAML's bad. There we go. So we deployed that. We'll go ahead and get our proxies. And now we'll see that we have got one and it's valid. You'll notice here that, again, we see the domain name, local.project.contour.io, and the status is valid. So if anything's wrong with your configuration, Contour will expose that here in the status field. And then we can describe it and get to a set of conditions as well to see more details about what might be wrong. So we'll go ahead and we'll just curl this for fun. So we'll do a curl and we'll see that we get this app back. And you'll see that, again, it's an echo server, and we're replying back with that static text here, that default app site. And again, here are the headers at the bottom, and then there's the request. So let's make this a little more interesting. So what we can do is we can do things like we can route with more information. So what I can do is let's go add a second app here. So this is called /secure. And we'll add this here. So now we're going to have two different paths. So this first one here is going to handle /. So you can see we have this conditions here, and this conditions is defined all the things that need to match to have that route be serviced. So by default, there's a condition of / that's in here just by convention. So I can actually add this, and it's the same thing. Here we're going to add a condition of /secure. So basically, this one's going to handle /secure to the secure app, and then / will go to the root app. So if we go ahead and apply this one, what we'll see now, I'll just open up a browser, it might be fun. We'll do local.project.contour. You'll see here is I get the root app at local, and if I do /secure, what I get is this secure app. Again, there's that echo server returning back. So yeah, so there's that. That's again not too exciting. This is what Ingress would do today. But I mentioned these conditions, right? So we can do things. We can add different types of conditions to here. So for instance, I could add a new condition that actually adds headers. So I could say, hey, the app needs to match /secure as well as the user agent containing Firefox. So this we're doing some header manipulation now. So if I go ahead and apply proxy 2, and I come to Chrome, what you'll see is I'm at /secure, but I'm getting the default site, right? And that's because to match this route, I've got to match the prefix of /secure as well as the user agent being Firefox or containing Firefox. And in Chrome, it doesn't happen. But if I go ahead and open up Firefox, it wants to update, go away. Okay, I got it. So now if I go to secure in Firefox, you'll see I get the actual secure site because you can see I have here in the user agent, it contains Firefox in that header. So you can do some routing that way. You can also do the inverse. So I can actually say the user agent doesn't contain Firefox and it doesn't contain maybe Chrome. If I go ahead and apply this one now, you can negate these. So if I come to Firefox and I hit this one, I'll get the default site because I do match /Firefox or the header having Firefox. But that's not what we want. And Chrome will do the same. If I hit secure, I still get the default site. But if I open up Safari and we paste this into Safari here, you'll see I get the secure site because I'm matching /secure and I'm not Chrome and I'm not Firefox. So again, these are silly demos. These are, these aren't that useful, but just trying to demonstrate that you can add these different kind of header routing manipulations to do certain things if you need to. You could have, certain browsers route to certain applications and have different browsers route to different applications if that was something you need to do, or based on your header routing, I guess is what I'm getting at. So that's the conditions bit. You can see that it's a list because we can expand them later. Right now we just have prefix, path prefix, and header. But future we could have different things there if we just decided to. So let's go ahead and deploy our marketing site. So I'm going to add to my demo here, and we're going to have this multi-team thing kind of come into play now. So I have this marketing team, and what they want to do is deploy a blog. So what I'll do is I'll go ahead and deploy some work for them. So what we have here is I've got a namespace for the marketing team. I'll just go ahead and show you my namespaces. I don't have one yet. I don't have a marketing namespace. So we'll deploy them in namespace, and we'll go ahead and give them, again, some apps to work with. So we'll give them this blog site here, and we'll give them an info site as well, which we'll get to next. So we'll deploy these resources real quick. All right, there's our namespace. There's our proxy, and then we'll do the app there. Cool. So now if I go ahead and get my pods and namespace marketing, what you'll see is I've got this blog site running. But now if I go ahead, we did deploy in here, we have this proxy. I have old demos in here. Let's just take this out here. Okay. So I have this blog site here. Again, it's in the namespace marketing, and it's going to route to the service, www blog. So if I go ahead and get my proxies now, what you'll see is I've got some errors here. So you can see I have the root one, which is valid. It's handling the local.project contour, but this child one here says it's orphaned. And it's orphaned because it doesn't have a delegation chain from a root proxy. So basically this extra resource that I created, no one's pointing to it. No one has any kind of delegation chain mapping to it. So Contra stalled this and threw it out because it doesn't have any mappings. So what we need to go is go ahead and tie those things together to be able to give it this delegation chain so it can handle that /blog. And what we do is we do this idea of this delegation. So in Contour, we call this, in Ingress route, we call it delegation. Now we call it includes. So what this includes does, we'll stick it here and I'll talk about it. This includes kind of works like software programming, right? So whenever Contour processes a site, it looks for these includes. When it sees it, it adds it to the, if you had a header file in a, say, C++ or something, and you reach an include, it's going to go find that code, stick it to the top of the file, and then continue on. And then when the whole thing's compiled, you have that header file in that new file there. This is the same way that Contour does it. So what Contour does is you can include things. So you can say, hey, I'm going to include this this other resource with these conditions and this namespace, and then Contour will apply that to that other resource. So long story short, what we're going to basically do is from the root here, this is where I have the root, I'm going to go say, hey, the resource called blog site and the namespace marketing is going to get /blog. So we're going to give them a delegation of the /blog prefix. Once I do this, then I will have a proper delegation chain from this root to the child down there on the other in the marketing site. Let's go ahead and apply this. Okay. Now if we go ahead and get our proxies, they should all be valid, and they are. Now if we go ahead and we'll just come to a browser, it'll be easier. If I hit the root, so the root app still works fine. If I hit /blog, that's what we delegated to them, I get the blog site. Again, it's running in the marketing namespace. Now, one thing to note with inclusion is that I've included the prefix /blog. But over here in marketing, I didn't define any kind of condition. And again, before we said conditions were, there was a default of /, and that's still true in this case. But what happens is all the conditions that are included are automatically applied this resource. So essentially, this ends up being /blog here. So if I added something else here, if I added, say, /foo, and if I apply this one, now what's going to happen is if I hit /blog, I'll get the default site because I'm only handling /blog /foo in the marketing team. If I add /foo, I'll get the blog site here. Again, it's through that idea of inclusion. So the idea is from the root, you include these different bits down to the child proxies. One thing that you might be thinking of is like, well, hey, if I'm this site running off in this marketing space, how do I know what I've got included to me? And I know it's vague right now because you don't really have a good way to do that. But there's a plan to add some of that information. So you'll notice if we describe a resource, there's a set of conditions on there. If I could type describe marketing and we'll do proxy blog. Isn't it called that? Oh, blog site. There we go. So down here, we've got a set of conditions here. And you can see that right now, it's just all valid. Our future thought is to have this have more information as to what's been delegated to it, what things are maybe wrong with it, and all that sort of information. So this makes it more rich. So this will help drive users trying to understand why something works or doesn't work, and also help you understand. We could drive external dashboards or any kind of information out of this from this one resource. Okay. Just to demonstrate too, let's save this, and I will reapply this again. Okay. We'll just add a header to here too, just to make this complete. So if I go ahead and say the header contains Firefox, maybe. So again, we'll have to match these conditions, and again, these are all applied down to the child. So if we apply the root again. Nope. What did I do? Oh, YAML gets me every time. Okay, so we configured that. We'll just verify our proxies real quick. Everything's valid. So now what should happen is that we should match /blog with the user agent containing Firefox. So I'm in Chrome here. So if I hit /blog, I'm going to get the default site because I don't match Firefox, but Firefox should work to /blog. It does to the blog site. Now again, that's there because all the conditions that are applied to this inclusion get applied to the child, and on the child we don't have any conditions applied, so that's kind of how that works. Okay, so that's conditions. So at 1236, let's do something fun. So a couple things else that Contour does is with our proxy CRD is that you can have multiple services in an Ingress resource. So this could be like a blue and a green deployment type demo. If you'd like, you can't do it with Ingress today. You can do it with label selectors, but it's kind of hard to do that. So here, Contour will tell Envoy to load balance across multiple services. So that's kind of cool. You can also add weighting to here, so you can give specific weights. If you want to put 80 weight to the blue service and 20 to the green, apply that and then kind of manipulate those weights to get to a point where you have 0 and say 100 or something. You can do weight shifting. Again, all these different things are sort of what we've talked about of removing the annotations out of the Ingress resource, so making this kind of a feature-rich API. So any questions from there? I'm going to bounce to Auth now. Auth is kind of a new thing that's kind of fun to demo.
So Tal, did you have one more question? I think you might have.
I do. I can wait maybe until you finish if there'll be time.
Yeah, there should be time. Yeah. I'm just going to demo adding Auth now to Contour, and then
cool.
That's all I have planned, and then we can talk and do whatever. Yeah, show whatever else we need to show.
Awesome.
Cool. So over here in I'll show you a little diagram quick that helps. So external auth. So how Envoy shows auth is, or implements external auth is through, again, gRPC. So what you do is you define an external service to implement your auth. So I'm going to demo today just the basic auth, but again, you could implement your own and have whatever kind of authentication mechanism you want to have. So here, first thing you do is we're going to deploy this auth service, right? And Envoy will talk to it over gRPC. Once you've deployed that may talk out to some sort of auth provider. In my demo, it won't because it's using local cache, but it could. And then we're going to deploy a new CRD called this extension service CRD. And what the CRD lets us do is lets Contour then kind of know about these external services that it needs to watch and manage. So in this CRD, we'll deploy all the details that match the service here that we've deployed. And that gives us a way to have some information as well, some feedback as to maybe this service isn't acting right. Again, a set of conditions to define the health of it. Once we have that, from our Ingress resource, we'll then reference this CRD and we'll enable auth. We'll say, hey, auth is enabled by this extension service, and then this service will get programmed into Envoy to handle requests. So when a new request comes in to your domain, it'll hit Envoy. Envoy will reach out to this external service, and it'll basically need to return to Envoy thumbs up or thumbs down as to should this request go through or not. Envoy then will either respond back to the client with, hey, you're not for when redirect because you're not valid, or it'll let the request go back into the application. So we'll go ahead and deploy that. So the first thing I need to do is I need to go ahead and deploy some TLS because I don't have we only do auth over TLS. So I will go ahead and deploy Cert Manager real quick. Once we have that, we will go ahead and deploy some bits. So I'm going to go create a service account and a cluster role, and this is going to be used for our auth service. So over here, this auth service is going to watch a secret, and the secret is going to contain the basic auth users and passwords. That's what that is. So I'm going to go create just a little cluster role and a binding to give that service account permission to go watch for the secrets. And I'm going to create a self-signed cluster issuer in Cert Manager, and that'll let me generate self-signed certificates. Let me just go into auth and then Cert Manager, and we'll do O1 prereqs. Oh, let's create my namespace. Project contour auth. I'm going to stick all this stuff in an auth namespace. And I can't spell contour. There we go. So now we'll go ahead and just apply it again because I mistyped all that. There we go. So we have, we have the service account, the role, the binding, and then that issuer. All right, now that we have that, let's go ahead and create our auth service. So again, this was I'll bounce around. This is this auth service here we're going to implement. So the Contour project actually has some example. There's one for unit testing we can implement, and there's this basic auth one. We're looking to help expand that as well. But you can also plug in any kind of Envoy external auth service because at this point we're just talking Envoy to the service, so Contour doesn't know or care about that endpoint. So you can plug anything in. I think there's one from Istio that has one that does like OIDC and stuff. Anyway, so we're going to deploy our own service here. So we're going to get a service for that, and then a deployment. And again, we're going to use HT password. We're going to expose port 9443. We're going to bring in some certs that we're going to go generate here from Cert Manager. Here's that auth server bit I just talked about from the Project Contour site. And that's it in here. So let's go ahead and deploy this. Okay, so there's our auth deployment. Let's go create the certificates it needs for that. So the first thing we're going to do is we're going to create this HT password one, and that's to secure the communication between Envoy and this external auth service. So we'll create that, and then this one is going to create basically a TLS secret for our incoming requests, so our client's certificate that they're going to consume. So we'll create these two bits. Okay, created those two. And what I should get is if I get secrets and namespace root proxies, that's where we are. I now have this one that's 4 seconds old. This Ingress conformance echo. And I should have one in the Project Contour auth site, which is also, 16 seconds old now for HT passwords. That's the Cert Manager doing its job, generating us self-signed certs. Okay, so there's that, and the next thing is we're going to create our backend secret database. So this is going to have, I did this ahead of time, but we basically have 3 users. We got user 1 with password 1, and user 2 with password 2, and so on. I created all these passwords, and I basically stuck them into this secret. Base64 encoded it, et cetera, and now that those 3 users exist in this database. So the Contour auth server will look at this secret to basically look at it for its database source of users. So we'll go ahead and apply this one. This is O3 secret. Cool, we created that. And the last bit to do is this extension service. Again, that was the bit over here. I'll bounce around. The CRD up here we're going to create, and it's going to help us tie it all together. So again, we'll put this in that namespace called Project Contour Auth. We're going to talk over H2. That'll let us do that gRPC connection, and then we'll pass it off to the service. The HT password we created in step 2. To deploy our actual service. So I will go ahead and apply our extension service. Cool. So now we have all the bits deployed. Now let's go to stick it all together. So first thing I want to do is I want to go ahead and make our proxy talk TLS, because right now we're not talking TLS because we don't have any certificates. So out here, we'll go ahead and get our secrets in root proxies. And here's our front secret. This is the secret that clients are going to connect to. So in Contour, I just need to add TLS and then reference the secret. All right, so let's go ahead and apply that, and we'll just verify this works. Let's go back. Okay, so now if we go ahead and do a curl for local, we should get a 301 moved. So again, here's another kind of thing Contour helps to do is you reference the secret from your domain name. So you probably want to redirect. Typically, you'd have to add annotation to say, hey, redirect from insecure to secure. Contour will just do that automatically out of the box because it sees the secret here. If you want, you can undo that, but you've got to annotate your routes to say, hey, or not annotate, but there's a permit insecure field you can do. Permit insecure, and that'll help. That'll let you route to this path without TLS. So we'll just go ahead and pass a -k to this. You'll see now we're serving TLS, which is good. So our cert manager cert worked. Now we're going to go ahead and apply. We're going to tell it to add our auth to here. So what we have to do is just have it annotate with some stuff. So we'll go down here and I'll just grab this little bit. And what we'll do is we'll say out here in the virtual host, we'll say we added TLS. Now we're going to add authorization. Get my YAML right. Actually, yeah. So this is actually in Project Contour auth. Now we're going to say, hey, for this virtual host, local.projectcontour.io, we're going to reference authorization to this extension service called htpassword in this namespace. So hopefully this is enough. Then add our service into there. We'll add O2 proxy. Cool, so we configured that. So now what we should do is if we do the same curl, what we get is a 401, right? So what happened was we configured everything. So now Envoy is expecting us to pass a basic auth user and password. So the request went and hit Envoy. Envoy redirected out to our auth server. The auth server said, hey, I don't know, the no user you passed me, and it returned back a 401. What we can do is we can go ahead and pass it a real user and password. So we'll just grab this. And this is going to go ahead and pass us basically user 1 with password 1, which is valid. And if I run this, you'll see that, hey, now I get the request coming through because the auth server matches user 1 and password 1. Just to make it clear, if I go ahead and change the password and make it wrong, say make it password 2, you'll see it's a bad password, so I get redirected, or I get a 401 return result. Last bit I'm going to show you is that how you can disable auth. So right now, essentially every route, regardless of what I hit, requires auth. But maybe I want to have my root site not need auth, but I want to have /secure require auth. So what we can do is we can come down into here and we can do that. So we can say, hey, the root app, which is this one, I can add an auth policy and basically disable it right there. So now this is going to say, hey, this route / doesn't need auth, but everything else is going to by default. So if we go ahead and apply that one, not my access key. Oh, come on now. There we go. So now if we do a curl to, we'll just do a curl to /. So / now does not need auth, but if we hit /secure, we do require that. So you can see now we've unlocked the one route, not needing auth, but everything else does. So I know that was a lot, and it was kind of crazy. I think that's all I have. So if you need help from us for Contour, we're the Contour channel and the Kubernetes Slack. You can find us on Twitter, on GitHub issues, anywhere that's helpful. And you can reach out to me as well. I'm at Steve Sloka everywhere on the internet. So hope this was helpful. Hope this gives you a quick intro to Contour. Again, there's lots more we could talk about, but I think we're out of time. So I'm happy to chat any more questions that folks might have.
I have a quick one to maybe kick us off, because I saw in your repo that you had you were beginning work on a Contour operator.
Yes.
Can you tell us a little bit about the status of that, and can I nudge you to getting it into operatorhub.io when you have even a beta or an alpha version for folks to play with?
Yeah, so actually we can. There are some folks from Red Hat that are actually driving that. So Danny and Micaiah are the two folks that are doing a lot of work with that. The goal there was to have another option to deploy Contour. So I think we're gearing towards the V1 Alpha 1 for December. I think right now it's functional. There's just a few more bits we need to add to make it a little more functional. And then from there, we'll have to come up with a roadmap to make that going forward, just to publicize that. But yeah, we can definitely work on that. We'll open up an issue to get it out into Operator Hub for sure.
Yeah, operatorhub.io is where we put all the generic Kubernetes ones. Okay. And if there's something specific that Damien needs to do to make it run on OpenShift, then it would go into the catalog. But yeah, I'm glad you mentioned that, because I just looked at the repo while you were talking, and I'm like, oh, another excuse to pick on Damien.
There you go. Yeah.
There you go. Perfect. Thank you for that. I know Tal has one more in-depth question, so I'm going to make sure he gets that in. So if you want to ask that, Tal.
Sure. Thank you. And thank you, Steve. Really, really interesting demo. And I do appreciate the taking seriously the authentication and TLS issues. My question is, I'm thinking of immediate comparisons to other products in this space. So it's a double question, I guess. But the first product I think is more obvious comparison is something like Kong. And Kong tries to solve similar things, but with a very different approach. Instead of working with Ingress, it has its own gateway. So all the Ingress goes to Kong, and then Kong it's all in one place. You do everything, right? All your policies, all your redirections, and everything there. So it's a different approach. I can see the immediate advantage of being, instead of having lots of different proxies, right, and delegations between them, you have a central place where you organize all your routing. So yeah, maybe you can talk a bit about that, and or maybe I'm totally wrong here. And the other comparison I would make, which is less obvious, is to Cilium. So Cilium obviously operates at a lower level. It will not do things, or at least not easily can do things like HTTP, HTTP routing. But, it takes over your entire Ingress, or it can, and also removes queue proxy from the equation too. I'm thinking back to my previous question about, if it's a daemon set running on multiple nodes and how you solve that routing issue. So Cilium does try to consider the whole routing, right, inside the cluster in that respect. Anyway, what are your thoughts in the Contour community about that comparison?
Yeah, so for the first one with Kong, so you mean that you have one giant resource for everything? Is that to configure it?
Yeah, it's like one service, everything goes to that, and then it will do all the rewriting of URLs and routing to whatever services you attach with all the rules and policies, etc.
Okay, I mean, that's essentially what Contour is going to do for you too. I mean, you're going to have you're going to have one service that's going to get all the traffic, and then I know I demoed like having Ingress across the cluster, spread all through it, but at the end of the day, that Contour is going to take all of that and create one big giant Envoy configuration. So essentially, yeah, all traffic is going to hit one or more envoys in your cluster, and then all that rewrite, all the routing, all of that stuff is going to happen essentially at that Envoy proxy layer. So I think we're pretty similar there. I know it comes up, folks say they're API gateways and such. Then I guess I don't really understand the difference between an API gateway and an Ingress controller for maybe just having some extra rules for rewrites and authentication and stuff. But I think we're still sort of in the same space, just using different technologies maybe under the hood. Or maybe I'm misunderstanding as well. But yeah, I think we're pretty similar though from how I understand how Kong works.
Yeah, I think we're going to have to get them on and make them do a briefing and explain how they work under the hood. So it's Kuma though that is the CNCF project, isn't it? Am I right or wrong on that? And Kong is the company?
Yeah, I think Kuma might be like their service mesh kind of offering. Yeah. And I think there's actually an Ingress controller as well that they have.
Okay. Got it.
Yeah. And your second question about Cilium, yeah, I mean, there are some interesting things that you could do with, if you control the networking stack underneath, Envoy or inside of Kubernetes. So, yeah, we don't have much, I guess, don't have any integration in the sense of being able to tap into that routing and stuff. So I'm not sure how that might look, but I could see where that could be beneficial. I know it's come up with folks where you can actually define like localities in Envoy. So like you could say, hey, this is this failure zone, this is a different failure zone, and then someone wanted to route requests to the shortest path instead of routing across the cluster like you might be leading onto. So if there's other ways to improve that traffic, that would be great. But I guess today Contour doesn't really dig into any of that low level bit as of yet.
Well, maybe a quick follow-up comment. What's interesting for me here is, if you look at the history of Envoy, when Lyft initially designed it, this is actually what they had in mind and not Istio. They really were thinking of Envoy as an Ingress controller, and kind of Envoy took on a life on its own later, with service meshes. But in an interesting way, this is going back to basics of what Envoy was thought of.
Yep. Yeah, I think there's a lot you can do with this. If you need a service mesh, that's a different kind of story. But if you just need some sort of routing that does sort of this stuff, I think that you can get a lot of functionality out of Ingress controller, API gateway, that sort of thing, without buying fully into a mesh. But they're different stories. Today Contour is focused on an L7 Ingress proxy. We've talked about L4. I know L4 is on the screen right here, but we don't do L4 very well just yet. And we'll have to see how where Contour evolves to do more of that sort of type routing.
Cool. So there's lots. One of the things that I love about this is Contour really hadn't jumped onto my radar until about a week ago, where we pre-recorded a panel with Nick Young and Paul Morey and Brenda Chan and from Istio Lin Sun and a couple other folks from that world. And so Nick regaled us with tales, which was wonderful. But it's amazing how many different pieces and parts there are to the service mesh and the serviceless ecosystem. So the more we can do to help grow your community and make it visible and get insights into what people are really looking for, the better. So thank you very much for coming here today. Totally appreciate it. We'll make Danyon dance around the operator soon and probably bring you back, and try not to wake up Nick Young too early in the morning or keep him up too late again. If you could go to your community page, if you could share your screen and show people where, if they want to get involved, how to get into the meetings, when your meetings are scheduled. I think that's maybe a good way to end, because you have meetings for 2 time zones, Australia and North America. Friendly?
Yeah, we do. Yeah, so there's couple different ways to get, I guess, and hold of us. So we have office hours every week. So we have it the first Tuesday, and so we alternate between U.S. time zone and Australia time zone. So the first and third Tuesdays, they're at 6:30 Eastern or 3:30 Pacific, and then in the Americas time zone, it's 1 p.m. Eastern and 10 a.m. Pacific. And again, it alternates every other week. And then every couple weeks we have office hours as well. So we carve out a few hours on a Thursday to go ahead and just folks can jump on and just ask questions, and we can demo things, and it's more of a interactive kind of time.
Yeah. But and I think the Contour site, I really like it because, well, one, it's really easy to find stuff on, and 2, that it's really very clear about how to get involved, having how to go from being an end user to a documenter to being a community participant, the whole ladder stuff. So you guys have done an awesome job creating a space for people to collaborate. So kudos to you all on that. And I'm really looking forward to KubeCon in 2 weeks, mostly because all of my talks are baked now, so I'm happy. And I'm wondering if there is a space that you want to talk about at KubeCon where people can find you. There's probably at least a couple talks on this, and not a BOF, but office hours there as well, too.
Yeah, there is. So the Contour team actually has a talk.
You want to? I'm not seeing your screen, so you're not sharing it right now. So if you're,
well, I should be. So I'm not sure. I'm not sure what's going on. I haven't stopped sharing.
No, you know what? It's me. It's not you. It's me. I've got the. Yeah, I see you right there.
Okay. Yeah. No worries. Yeah. So we actually have on Wednesday at 3 o'clock. There's for all the maintainers here. We have a talk just kind of outlining what you just saw in a way. So if you want to see it again, we'll do sort of the same demos again. And then there are office hours throughout the week. I think there's 2 different sets of those. So if you search for Contour, there are different office hours that will be available to chat as well. Yeah. So we'll be very, absolutely.
Yeah, and if you're coming to the OpenShift Commons gathering, that the panel that I was blathering on about a couple of times is on November 17th, and it's I think it's later in the afternoon, like around 2. No, not 2. Earlier than that in the day, but I'll post that as well with there. And that was actually a really good exploration of the space. It's called To Serve or To Be Served. the serverless microservices and service mesh, and it's not in the KubeCon schedule. It's in the it's buried. It's buried. You couldn't find it. It'd probably take the whole time to find the click through to get to there. But suffice to say that there's going to be a real good deep dive on serverless, good conversations at KubeCon about that, and at the OpenShift Commons gathering on day 0. So there'll be plenty of content for you to binge watch afterwards on this topic. And I do suggest that you do reach out to the community project. Contour.io is a great site, and it's a great project, and I'm really happy to see you in the space. So thanks again, and we'll probably see you at KubeCon in some virtual chat room. So take care and have a wonderful day, and thanks everybody for joining us.